So this is problem 50. In problem 50 you've got the box on the incline and it tells you that there's friction. So I do have a frictional force. Now you need to figure out what direction the friction is going to go. Without any friction, the box is going to slide down the incline. The force it's holding there is just there to complement friction to hold it in place. So without those it's going to go down the incline, which means friction in this case has to go up the incline. Then you got a normal force, normal to the incline, perpendicular to it. And finally, because it has mass, it's going to have weight, which we're labeling as mg. So the final force to go with is the one that's applied. It says it has an applied force that's horizontal. There's my applied force. Next thing I need to do is establish an x and y coordinate plane. So I'm going to choose parallel and perpendicular to the incline, and I'm going to make it go up the incline as positive, although you could choose down. It's fine. And then I look at my forces and see which ones are parallel and perpendicular. So if I look at the friction, that's fine. I don't need to do anything to that. Normal force is fine because it's perpendicular to the incline. So friction's parallel, normal force is perpendicular. mg is not perpendicular or parallel to the incline, and neither is my applied force, F. So what I need to do is break F up into components and mg up into components and do parallel and perpendicular components. That's parallel to the plane, perpendicular to the plane. So F becomes F cosine theta, with theta being 60 degrees. And that makes this F sine theta. And so now my two components are parallel and perpendicular to the incline. And then for mg, I'll make mg the hypotenuse of a triangle, where I'll make mg cosine theta, and then mg sine theta, and again theta is going to be 60 degrees in this problem. So now when I'm summing up the forces, I'm basically going to ignore F and ignore mg and just work with these components that I've just drawn on the screen. Summing up the forces in the x direction, it's not accelerating, so that's equal to 0. And I'm going to say all the forces going up the incline, so F cosine 60 plus friction, minus all the forces going down the incline, minus mg sine 60. So I'm just looking at the forces that are going horizontal. Vertically, sum of the forces in the y direction is equal to 0 because it's not accelerating. And that's going to say all the forces going up, which is just eta, normal force, minus all the forces going down, and there are two of them. mg cosine theta and F sine theta are going down. Next step I asked you to do is to put in some numbers, any numbers the problem gave you, and so this is what it looks like with those numbers.